Bismillahirrahmanirrahim. Assalamu alaikum. This is the new reduction formula for the integral of cotangent power n of x with respect to x. So in this lecture I will find the reduction formula for the integral of tangent or cotangent power n of x with respect to x. If you people are in first time in my channel, then please subscribe it and press the bell icon for the next videos. And if you have any problem in these lectures, you can ask me in the comment section, or I will share my email address with you in the comment section, and you can ask any question of mathematics from me. So reduction formula for the integral of cotangent power n of x with respect to x. So far we have worked through the step to derive the reduction formula for the integral of power of sine, cosine and tangent of x. Let us now have a look at how we can derive the reduction formula for integrating power of the cotangent function. So I will proceed this equation. This is integral equation which is equal to I n. So as it turned out, encounter deriving the reduction formula is easier than reduction formula is easier for cotangent power n of x for sine and cosine. The first step is the same. Break up the integrand, this integrand, into multiple of power. So cotangent of n of x is equal to cotangent power n minus 2 of x with cotangent of x. Because basis same power will be added, so cotangent power n minus 2 of x is equal to n to cotangent square of x is equal to cotangent power n of x. So we can substitute these two functions in the place of this single function, which is equal to in is equal to integral of cotangent power n minus 2 of x with cotangent square of x with respect to x. This is the first step. After this step, the below steps are very easily to solve, are very easily to integratable. So it is equal to, we are familiar with the Pythagorean identity, which is 1 plus cotangent square of x is equal to cosecant square of x. So shift this one to this side, so cotangent square of x is equal to cosecant square of x minus 1. So substitute this value here in the place of cotangent square of x, which is equal to in is equal to cotangent power n minus 2 of x into cosecant square of x minus 1 with respect to x. Dx is basically differential of x, so this denoted the integration is with respect to x, so I call it with respect to x. So in is equal to multiply this cotangent power n minus 2 of x to these two terms, so it is equal to cotangent power n minus 2 of x with the cosecant square of x minus integral of cotangent of n minus 2 of x with respect to x dx. So after this is very easiest, we can directly find its integration, but you guys will misconfused and they will be confused in these steps, that how I take the direct step. So let u is equal to cotangent of x, so du is equal to minus cosecant square of x, so minus will be shifted to this side, so minus du is equal to cosecant square of x dx. So substitute these values here, so it is equal to in is equal to integral of cotangent of x is equal to u power n minus 2 and cosecant square of x dx is equal to minus du minus integral of this is equal to cotangent of n minus 2 of x dx. So it is equal to in, it is equal to u power n minus 2 plus 1 divided by n minus 2 plus 1 minus integral of cotangent of n minus 2 of x with respect to x plus c. So we are going to the reduced formula for integral of cotangent power n of x, which is equal to minus u of n minus 1 divided by n minus 1 minus integral of cotangent of n minus 2 of x dx plus c. We will write plus c after finding this integral. So in is equal to minus u of n minus 1 divided by n minus 1 minus, if I denote it, integral of cotangent power n of x with in, so it is equal to in minus 2. So shift this in minus 2 to this side, so I of n plus I of n minus 2 is equal to u power n minus 1 divided by n minus 1, and u is equal to, resubstitute again the value of cotangent of x. So in is equal to in plus in minus 2 is equal to cotangent of x power n minus 1 divided by n minus 1. This is the reduced formula I of n. So integral of cotangent of n of x with respect to x is equal to cotangent of n minus 1 of x divided by n minus 1 minus integral of cotangent of n minus 2 of x with respect to x. This is equal to integral of cotangent of n minus 1 of x. This is the reduced formula. So this is the steps that I have followed in these lectures. If you people have any question in these steps, you can ask me in the comment section. So this is we can say it we can integrate in a short time that how cotangent power anything, cotangent power 3, 4, 5 or 6, whatever, we can find its integral. This formula facilitate us by finding its integral. So this is cotangent of x. If in short, suppose someone give me that find integral of cotangent cube of x with respect to x, so I will compare this function, this integral, with this reduced formula. So cotangent here n is equal to 3, so it is equal to cotangent of n minus 1, 3 minus 1, which is square of x divided by 2 minus integral of n minus 2, this is n minus 2, so 3 minus 2, which is only cotangent, so cotangent of x dx. So integral of cotangent of x is equal to integral of cotangent of x is equal to cotangent is equal to integral of cos divided by sine dx. So cos divided by sine, in the denominator there is sine x, in numerator there is cos of x. So in two function, the denominator there is sine and the derivative of sine is cos of x. So the integral of this function is equal to log of sine of x plus c, which is cotangent. So integral of cos cube of x is equal to cotangent square of x divided by 2 minus log of cos of x plus c. This is the formula. So in short, we can find any integral of cotangent power n of x. We can find integral of cotangent power 10 of x, integral of cotangent power 9 of x, integral of cotangent power 11 of x, up to integral of cotangent of 100 of x, integral of cotangent power 1000 of x. We can find any integral with the help of this reduction formula. So guys, how are the today lecture? And please, if you like it, this video, this lecture, then please like it and share it with your friends. Thanks.